Hi, welcome to PySquare Academy, myself Sekhar. In this video, I'm going to explain another theory versus practical concept. Okay, I'll be demonstrating you in this lecture about the closed loop control system. Closed loop control system. In one of our lecture, I had discussed how to design a closed loop control system. Okay, practical demonstration I have given. You can check the link in the description. Okay, so but in this lecture I'll be giving you the details of, I'll be demonstrating the details of overdamped case and underdamped case and critically damped. Okay, I think you know these aspects. You must have studied definitely these aspects during your control systems, but you never experienced, what is this critically damped, what is this overdamped. Theoretically, but practically you must have never experienced it, right? So in this lecture, I'll be giving you the demonstration of that practically by taking a simulation. Okay, so for that, showing you that simulation, I'll be using this design which I have already explained in one of our previous lecture. That's what I said. You can check the link in the description. And our courses, control systems, full courses have launched. You can take the courses. Almost every concept we beautifully designed so that you'll get a practical feel also. Okay, you can have a look now how the control systems will be. So this is the control system. What we're considering the DC motor speed control. Okay, at the reference side, this is a reference where we're entering some value 500 RPM. So accordingly, I should get the DC motor should give the same output. Okay, so this is what the objective. Automatically, the moment I change the input value here, the output, I should get the required value of output. Okay, required speed, I mean. So here I have different controller settings. This is the controller. I have different controller settings. I can set it to underdamped case, overdamped case, critically damped case. Okay, so it is already at 500 RPM. So it is giving almost 500 RPM. Okay, so let's now talk about overdamped case. Okay, let me discuss overdamped case, and I'll change the speed, the reference speed to 1000 RPM. Okay, 1000 RPM, I'll set it to 1000 RPM. And see, the moment I change it to 1000 RPM, slowly this output is increasing, right? DC motor speed is increasing. See, because we know if a reference value is this is the reference value. In case of a critically damped case, it will slowly increase to final value. Okay, see the changes. Speed is increasing, right? It's going close to 1000. It will reach 1000 after some time. Now, what if this would have been underdamped case? In case of underdamped case, what you'll get? In case of underdamped case, you would be getting some oscillations and it will be settled like this, right? So let me change the design. Of course, it will take some time to reach its final value. Okay, I'm changing to underdamped case. Now let me change the value of speed so that you can feel it. Okay, observe carefully. I'm changing this reference value from 1000 to 1250. Okay, now you check the output, check the instrument deflection. Okay, how it is changing, so that you can feel it much better. The same speed display that's been kept with this instrument so that you can see the oscillations. Okay, yeah, boom. See the oscillations here. It's oscillating and finally it is settled to 1250. So it has gone beyond 1250, again coming down like this, oscillating. After some oscillations, it has reached its required value. Okay, let me change it to 1000. Yes, see the oscillations. And after some oscillations, it has settled at the reference value. Okay, so obviously we don't expect in this case this to oscillate. Okay, and we don't even expect to take long time to reach its final value, not even like this. Okay, so we go for this specific design, critically damped is obviously the best. Let me change it to critically damped case. Okay, so critically damped case, what will happen? it will take minimum time to reach its final value. Okay, I set it to critically damped. Let me change it to 1250. See, yes, it has reached 1250. The input is 1250, so it has reached 1250. Let me change it to 1000. Yes, it has reached 1000 already. 750. Yeah, it's reached 750. Okay, so any speed you are setting, it is at the least possible time it is reaching that speed. Okay, that's what critically damped is. I hope you understand, right? Because theoretically you must have seen the oscillations and all these things. Now you must have felt that. Okay, let me quickly keep all those things once for you. For underdamped case, see the oscillations, we're having oscillations. Okay, now you when they change something, the moment you change the reference value, see oscillations are coming and finally settling to required value. Okay, but if it is overdamped case, it will take more time to reach its final value. It's slowly taking its own time, okay, to reach its final value. Okay, so this is what about the automatic control. This is how the closed loop control system works. These were the different cases. Okay, different cases as in underdamped, overdamped, all these cases. I think you must have felt it. If you like the video, hit the like button and share this video with your friends, definitely. Okay, more number of shares you do, definitely we'll be coming up with more number of lectures. Okay, and if you are new to the channel, don't forget to hit that subscribe button and ring the bell. Why to ring the bell? Because whenever we upload a new video, you're not gonna miss it. Okay, you're never gonna miss it rather. That's it. That's the end of this lecture. And as I said, our full courses are launched. You can check the link for the description. Control system full course. The course is explained with complete demonstration. Okay, whenever there is a requirement of putting up demonstration, we'll keep the demonstration. And you can take the free trial course. Okay, you take a free trial course, then enjoy the course. Okay, that's it. Thank you. See you in the next lecture.